everybody, welcome to a new live coding tutorial. This time we will talk about object storage and how you can mount object storage in the cloud as if it's a local directory on your local file system. So let's dive into it and see how that works. First of all, first things first, of course, let's get to the tutorial. So you can get to the tutorial by going to ibm.biz/S3FS-FUSE. S3FS-FUSE. Yeah, that should forward you to this Medium tutorial, and all the instructions are in here. So you can work at your own pace from here, or you can follow along here with me. The object storage that we are going to mount as a local file system on our local client, it's using something called Filesystem in Userspace, or FUSE. We will talk about that. And it's using S3FS, which is a object storage variation of FUSE. It helps you mount object storage. And it's using an IBM Cloud account where we create an object storage. Yeah, so that's what we're going to use. We're also going to use a client terminal at labs.cognitiveClass.ai. I've tried this tutorial on my local Mac. It works as well. You can do that as well, but you'll need to install the IBM Cloud CLI. And on the labs.cognitiveClass.ai, most of the tools are already installed. All right, so let's start a little bit background information. A little bit background information about FUSE. It stands for Filesystem in Userspace. It's a kernel-based, part of the Linux kernel, I should say. It allows you to let non-privileged users, non-root users, to create file systems in their user space, in their user environment. The FUSE project has two components. It has a kernel part called FUSE, File System in Userspace, and it has a Userspace library called libfuse. And the two communicate with each other. And they send requests to create, read, update file systems back and forth. That way, the user from within the user space can have these root privileges on the file system. All right, here's the diagram. Yeah, not much to it. In addition to using that Linux kernel principle of FUSE, we will use an S3FS package. And what that does is it allows us to use FUSE against an object storage. So rather than creating file systems on my local machine through FUSE, I can now create remote object storage as if it is a local file system. So that's what we can do with the S3FS. What does the S3 stand for? S3, as a reminder, stands for Simple Storage Service. It's the name of Amazon's original object storage service. And what object stores let you do is, object stores, in contrast to direct disk storage like block storage, it creates a API to interact with the disk. Yeah, block storage will write directly to the blocks on the disk. File storage will use NFS, Network File System, for instance, to write to the disk's storage, and it's using NFS as the file system manager layer. But S3 uses an API-based interface. Now, that means you can send APIs requests to read, write files, update files, create directories, etc., symbolic links, anything you use to on a regular file system. For applications, that might have the advantage that if you have an application that needs to do shell commands against the file system, like ls or copy or move, then it can use that, but it'll get executed against the object storage using the S3FS. So that's pretty cool. It's performance-wise not as good, obviously, as writing directly to your local file system, but you can get some pretty good performance out of it. The other thing to note before we dive into it is that this is also, as a use case, for instance, useful if you have containers deployed, an application deployed as a container in Kubernetes environment. Typically, your Kubernetes environment lets you create persistent volumes and a claim on that persistent volume as a cloud-native way of mounting storage and making that available to your application. Now, because object storage is API-based, there is no core way of doing it in Kubernetes. But with S3FS, you can actually create persistent volumes and a persistent volume claim against the volume as if it was a regular storage. It's using a out-of-tree principle of flex volumes to do it, and it's using a flex volume driver and the FUSE principle against the flex volume driver to mount those remote object stores. Yeah? And how that under the hood works, we're using S3FS and FUSE. That's basically the objective of this tutorial. Amongst others, there is a IBM Cloud Object Storage plugin, here it is, that's using S3FS-FUSE. And the way it works within the Kubernetes environment then would be that here you see sort of a diagram of your Kubernetes cluster. You have your container deployed here with a volume mapping for writing to storage, and you can then map that volume to a persistent volume claim and persistent volume by using this kube flex driver here and right next to it. And that then has the additional functionality, that is the plugin has the additional functionality to provision the persistent volume for you when you create the claim. And it also manages the authentication through the secrets and the relevant storage class to map to your object storage. So that's all additional features of this cloud object storage. And that is one abstraction that allows you to sort of abstracts away the implementation details for object storage on a Kubernetes platform. Yeah. You have other principles like Ceph and Rook.ai that are also really interesting in that regard, but this in particular looks at S3FS, just for the fun of it, because we can. Okay, so let's go back to the instructions. So let's start by going to the labs environment. So we are using labs.cognitiveClass at AI here. This is some old work I have, but we can actually use labs.cognitiveClass.ai. Yeah. This will actually, what I need to do is actually clear my browsing data, so you'll see more similar experience of what you will be seeing. Then if I go to labs.cognitiveClass.ai, you will see, first of all, a pop-up appear. The labs at the Cognitive Class are part of Cognitive Class.ai, which is sort of a learning platform. You can get badges and tutorials and classes on a range of topics, like data science classes around Jupyter Notebooks, machine learning. You will find classes and badges around containers, Kubernetes, OpenShift, and a range of other topics like blockchain. List is pretty long. It's pretty cool stuff. But it comes with labs environments like a client terminal or a IDE, so to support those labs. Now we're making use of this. This note is meant, this attention note, it's meant to make you understand that this is to be used for those learning purposes. So all good there. I'm using the Cognitive Class login button. You can create an account or sign up using different social login. I'm using my IBM ID actually. So I click the Cognitive Class button here, and you can either create an account if you don't have it yet. You can pause the video and sort of create an account there, or you can create an IBM ID and use that to log in here. That's what I did. my IBM ID is this one here, and my password for the account. So that uses federated login. It redirects me back to the skills network. And that lands us, and I make the font a little bit smaller so you see where it lands me. So that lands on all the different labs environments that you have. On the left side, you see a lot of data science classes. On the right side, you see these Docker and OpenShift environments. I'm going to use the Thia environment with Docker here. It's a cloud IDE. It's a browser-based IDE environment. That's pretty much Visual Studio in the cloud and in a browser. So that's what I use here. This will start up the environment. It has some tooling pre-installed. IBM Cloud CLI in particular for our purposes here. kubectl is installed. If you wanted to interact with Kubernetes, OC for OpenShift interactions, has a bunch of other tools. So this is pretty useful to use for environments. This will take a while because what happens, it pulls an image, deploys it to a Kubernetes platform, spins up an instance, installs sort of this Thia environment and some other client tools. As you see here now, we're in the browser. We have Visual Studio in the browser, and we need to create a terminal environment. So here, terminal, new terminal, we'll open a terminal environment here at the bottom, and let me increase the font size so you can see it better. And if I do IBM Cloud CLI, version here, you will see the version of the IBM Cloud CLI. It's already pre-installed. If you use this tutorial on your local machine, you will need to install the IBM Cloud CLI, and you'll save yourself some trouble here. If you do want to install it locally, you can go to the instructions here on this link, or you can run this curl bash pipe command, and it'll run sort of the installer. Once you have access, though, to the IBM Cloud CLI, we need to log in. So IBM Cloud login. I like to add the -u to add my username. Otherwise, it will prompt it. So you'll get prompted to fill it in anyway, but I like to add this information on the command line. Ask me for my password. Authenticates me, and if you have more than one account attached to your IBM ID, then it will prompt you to select the account. In my case, I have only one account. It defaults to it, and it's good to go. So I'm not sharing use statistics. I don't want to update. So that's good. So I'm logged into my IBM Cloud account ID. And by the way, if you do not have an IBM Cloud ID yet, you can create one. So you can create one by going to cloud.ibm.com. You can click the create an account here, or you can just continue here to log in. Yeah, so I'll log in here to my account. I realize that I actually have the previous object storage that I used still open, so I'm going to have to delete that first. So you see here, this is sort of my dashboard. If you log in, some starter links there. Here's all my resources, and like I said, I tested this lab before, so I created a storage object that I forgot to delete. I'll do that right now. Yeah, so you see a little bit of admin here going on. So we'll start from a clean sheet here. So this object storage is being deleted, and there it is, it's gone. So now I can start just like everybody else with nothing in my resource list. You could do this through the UI, so you could create a object storage instance in the catalog. So here in the top you have a catalog. You can search for object storage. So I think here you can also go to storage here on the left. It'll pop up as object storage here, and it'll go to the create object storage. And you can use this create a free light account here. You will have to rename it and set the name in our terminal. I'll show you later. You can give some tags, use the default resource group. So that's all good. And yeah, so you can do it through the UI. Now, I prefer to do it through the CLI because one of the reasons I sort of got into this practice of doing as much as I can through CLI, and because it allows you to automate what we're doing here manually. And automating this is according to the principle of everything is code. So just a good way of thinking about coding in general, to think of everything as codable, automatable. So one thing we need to do here, this is if you wanted to do it through the UI, but we're going to create it through the CLI. Let me take a sip. So if you wanted to create it through the UI, we first set some some environment variables first, COS name and resource group. These environment variables is typically what I do, so then later on everybody else can set their own environment variables and copy paste the same command. So it's just easier for everybody probably. First set the cost name, and I use my username. You can use your username. Then dash cost for cloud object storage -1, as in case if you wanted to use multiple numbers. That's one. And the other one is resource group. Same to default. Yeah. It could be that you have an account that already has a resource group. So actually what you can do is you can list all resource groups. So let me delete this. You can list all resource groups that are currently on your account. Now, I already have a resource group here. So what I do is I set my resource group name to the name that is listed here. So that's uppercase D default. If you do not have a resource group name listed here, you can set it to either to this default, or you can set it to a lowercase default, and you can create a resource group with this command: IBM Cloud resource group create, and then the resource group variable that we just set. But in my case, I already have a resource group, and we need this resource group when we create some resources later on. Yeah, so here we actually create the object storage. So one thing that I sometimes do is keep a file open here on top of my terminal using the Thia IDE environment. So this is the command that we're using. And then for those people that are typing along, I keep pace if I type along as well, right? So IBM Cloud resource service create. So this is the IBM Cloud admin create service instance create. Sorry, instance create with the cost name. And I forgot if we set it already. Did we set it already? Oh yeah, we set it already, right? The cost name, which is the name for the cloud object storage instance. We are creating an instance of cloud object storage. Yeah, that's the resource we're creating. We're creating a light plan, which is free, uppercase L, light. Global, and the resource group, which we create this in, is set to this default value that I already had. So we create the service instance in resource group default, and it should, let's see what it creates here. It gives me a global unique identifier, gives me some other details when it was created, etc. So this was successful. That's good. And if you wanted, then the next step in, and maybe we can actually see it in the object storage here. So let's go here to the top left. If you click the IBM Cloud logo, you go to the resources listed. Yeah, so you see that there's now one resource added. We previously deleted one, but here's a new one being added, Remko dev-cost-1 in the resource group, location global. Yeah, so that's what we, and if we click this instance, it will go to the object storage dashboard. By default, it takes me to buckets. You see there's no buckets at the moment. And that's what we'll actually be doing next. So you could create a bucket here through the UI again, and you can follow the instructions. I like to do this again through the UI and CLI, I mean. And by doing it through the CLI, I first need to create credentials because I need to authenticate myself when I create buckets in this object storage. And I first set a credentials name. Yeah, so I set an environment variable, cost credentials. This is going to be reused throughout the tutorial later, so this is useful to have here as an environment variable. Cost credentials 1. And if I would go to the cloud object storage, you can see here in service credentials that there's currently no service credentials here. But it will only allow me to create a bucket through the CLI if I first have credentials to authenticate myself, which just makes perfect sense. And we're going to create the service credentials, and we need the hmac keys for authentication. So that's why I set these parameters here at the end. But let's step through this here. So IBM Cloud, I'm going to use the resource plugin to create a service key. So service key create. I'm using the environment variable that I just created to name the service credentials. COS for Cloud Object Storage credentials. I give it a writer role because I want to write. And the instance name of my object storage is set in this environment variable I created earlier, cost name. And like I said, the parameters, which indicates that I want to add a particular type of credentials, I set that to, in this little JSON object, hmac to true. So it'll create hmac credentials for me. Yeah, this will see here. So you see like a whole bunch of credentials. So let me scroll up a little bit and step through this. Here it is. It gives me a service key, which is this whole long conglomeration, a name, a ID, which starts with CRN. CRN is like a cloud resource name. So it's just a standard of doing it. It created credentials, an API key, but also hmac keys. Yeah, so in the hmac keys, it gave me a access key ID and a secret access key. These are used later to authenticate the S3FS plugin when it tries to mount the object storage onto the local file system through FUSE. It needs to authenticate itself because this is a protected object storage. So I'm using these hmac keys here, right? Yeah, so that's what that's doing. An endpoint. And let's see what else is here relevant to mention. Yeah, okay, this is just a bunch of other things. So that's good. I created my credentials. Yeah, I mentioned here that it's creating these hmac keys. And the next, I'm going to list my object storage instances. I have one created, as you you saw, and this will this sort of lists the configuration of the Cloud Object Storage plugin for the IBM Cloud. And you see, like, one thing to note is that there is no CRN or custom resource name set for my object storage plugin. So that means that I first need to set that CRN, because it is, when I try to authenticate and create a bucket, it will look for the CRN to match to my keys, and if it can't find it, then it's going to not authenticate. You get a key not found error back. So that's what you need to do first. Let's see here. I can, if I copy paste this first set where it's lists the keys, because remember we created, and I can remove the output in JSON format. So this will, IBM Cloud's resource, service key, and then the name of the credentials I created. It will pull down the credentials I created earlier. Yeah. Amongst others, I mentioned that there is a CRN set. Let me see where it is. Here's the CRN set, right? The ID. And I think service ID, CRN, it's listed here as well. So that's what I need to retrieve. And when I execute this IBM Cloud Resource Service Key cost credentials, I set it to the output format of JSON that I do here. And then I pipe it through a command, like a shell function called JQ. I remove double quotes, so it's like readable. And I parse my JSON basically. Yeah? It's an array, so I get the first listing because I know it's only one credential. I get the first credentials, the first listing in the credentials there. In the credentials, I look for the resource instance ID, and that is basically my CRN, and I parse it out and set it to an environment variable cost_CRN, and then to check if that was set correctly, I echo that environment variable out. Yeah, so that's what I do there. Copy paste it here, so I'll type it out here for people who want to type along with me. Cloud Object Storage CRN environment variable, I'm setting the value to $parenthesis to open and interpret the output of the following command, which is IBM Cloud resource. I'm retrieving the service keys with name of the credentials that I had created before. Yeah, so I'm retrieving a particular, not the whole list. I set the output to JSON just for the simple purpose in order to parse it out as a JSON object using this JQ functionality. I remove the double quotes and I'm looking to parse the first listing in the array, and within that first listing I'm looking for the credentials property, which has a resource instance ID, which is my CRN, my cloud resource name. Yeah, and then I parse that out. I double check if that was, because sometimes it's easy to make mistakes with such long commands. I make sure it was set correctly, and yep, it looks like it was set correctly, and that means I can move on. Next, I configure the configuration for the Cloud Object Storage plugin. You saw earlier that with this IBM Cloud cost config list, now I can do it again. IBM Cloud COS, Cloud Object Storage plugin, config, and then list my configuration. You saw that my CRN is not set. So I can set my CRN by using the IBM Cloud Object Storage plugin config, and then set the value for CRN with the CRN flag to the environment variable that in my previous step I retrieved with that parsing out of the JQ function. Oh, what I COS CRN. So cloud object storage CRN. So this is now should set, and if I go up, if I scroll back up with my arrows back up, and I go back to the IBM Cloud COS config list, it now should have set my CRN, and there it is. And I need that because when I use this COS plugin to create a bucket, it will look for the CRN setting, and that's how it lets me create it. So that's good. So now I'm ready to create a cloud object storage bucket, and I set an environment variable, COS bucket name. And the thing to mention here is that IBM Cloud buckets need to be globally unique. So across the IBM Cloud, you have to make sure that your bucket name is unique. One way of doing it is using your username amongst others, but it's possible that someone else happens to be using a similar username. So I always, let's see what I'm using in the tutorial. Oh, I'm not using any, I didn't specify it here. But what I typically do is I say B for bucket, I give it a number, B1, and you can give it, so a random little string, even if it's just 4 strings long, just randomly type something. Add a number to it. So I set my COS bucket name. I hope this is unique, and you need to make sure it's not what I do, because it'll throw you a not unique error. And then we can use that name here in this next command. In this next command, when I step through it by reading it out loud, I'm using the IBM Cloud CLI, this Cloud Object Storage plugin, to do a bucket create. Yeah, it sort of reads itself. And I set the bucket name to the COS bucket name environment variable I just set, with hopefully a globally unique name. I set a class to standard, and I also set the IBM service instance. Oops, I'm not typing that. The --IBM service instance ID to the COS CRN, the cloud resource name for the object storage. So now it links the bucket to my object storage. Yeah. So, and that's why we did the previous step of configuring the CRN. So hopefully that goes all well. So it did. Anything to note here? Apart from that, it went okay. It set a region and a class. Now, if I go back to my UI, so first of all, if I reload the service credentials, it should have those service credentials set. And you can do this through the UI, actually. You see that it's set to type hmac. I believe if you use the new credentials advanced options, you can switch on this hmac credential. Yeah, so that's how you need to do it there. But I already have one, so I don't need to do it again. In my buckets, I should now have a bucket. And hopefully it will show up here. Reload the page. I'm not sure why it's slow to load. Okay. So, and here it is the bucket, and it will show my name and the unique name I gave it, including this little random string at the end. That's cool. That's cool. What else do we see here? There's no policies, no rules, nothing else set, no trackers. There's no encryption. So one thing to note here, if you do use the create bucket, you can use a customize your bucket option, and you can sort of give it a name, right, and make sure it's globally unique. You see that here in the naming rules. So if you want to go through the naming rules here, then you can set it look at them here. You can choose your resilience for high availability and cross regions, regional or single sites. You can choose your location, and you can do all of this through the CLI as well. You can retrieve your regions, your locations, etc. Storage class. We use the standard actually, but you can also set it to smart tier through the UI by default. But here's the other ones, the other options. So you can add archive rules, you can set expirations, retention policies, typically done here. And also you can set encryption. Cloud Object Storage here uses sort of a slice and secure slice method. When you submit your object, it gets chopped up, or gets encrypted, I should say. It gets chopped up and distributed on different storage locations. And then when you retrieve your object, it gets pulled together again, decrypted, and sent back. So that's a secure way of storing. That's why this is a neat. And object storage actually allows you to really get like serious encryption standards like FIPS 140, which is sort of a hardware-based encryption that's enabled on here. So that's like pretty neat if you need to dive into that. But for our tutorial, that it goes too far, right? So let's go back out of here, back to our buckets listing here. That's fine. All right, we did this. Got sidetracked a little bit. We're basically so to resume what we're doing, we created an object storage, we created a bucket, and we are now ready to upload a document to our object storage. Yeah, and the reason why I upload it to the object storage now is so that later we can actually use the S3FS local directory to read it back in and interact with it from the local directory. But I want to do it like both ways, and it'll see that it sort of links the object store back to your local file system. So that's what we'll do next, and then so let's first create a new document, and I create a new document with this object key that I set, and I did it this way because I need the object key as a key from the object I'm uploading, and I just decided that I use the file name for it for convenience. So let's clear this out first, and let's show you what I'm doing here. So first I set the environment variable for COS object key, and I give it just a file name. So hello world.txt, that's my key. Then I echo out a hello world. I add some, I inject sort of this function date. This will inject what date is, January 8th, I hope, today. Double quotes, and I sort of push this into the file name, and I can use the COS object key here. Yeah, and then if I do an ls-al, you see there's now a hello world.txt file. I can do a cat to output what's in there. And you see here now, what's in there is hello world. Today is Friday, January the 8th. It's UTC time, 8:54, 2021. Happy New Year. Okay. And now we need to upload it. So I can use this command here. IBM Cloud, COS, upload, -- bucket. And if you need to upload like a multi-part method because it's your file is too large or your object is too large, you can do that. Look at the documentation. It'll ask you to create a multi-part upload and then repetitively upload it and then finalize it. So that's all written out in documentation, but for right here I just use a single one. Yeah. So I'm using the bucket name, -- key set to cos objects key. Yeah, so I need that key, which is the file name. I do a -- file, which is the actual file that I'm uploading. And in this case, it's the -- hello world.txt. Content language is set to English US. And the content type is set to text plain. And enter. So now hopefully it will upload this. It says OK. And if I go now to my UI, into my buckets, I should now see, there it is, my objects uploaded here. So before we move on, let's recap. What we did is we used the terminal to create an object storage instance. We created a bucket within the object storage instance. We configured it so we can access it and see, and we uploaded a document, right? So that's good. Now the next step is to mount that object storage so we can access those objects in the object storage as a local directory system in a local environment. So far we've been using the labs environment at the cognitive class.ai that was right here. This, however, is running in a public cloud. It's running on Kubernetes in a containerized environment, and the security settings there do not allow us to interact with the underlying FUSE kernel, understandably. So in order to make the S3FS actually work, we need a physical Ubuntu environment or a Mac operating system. So in my case, I will switch to my local Mac for that. And it's kind of nice because it's sort of conceptually we're sharing documents. Someone else wrote something to an object storage, and in a different machine, I'm now going to mount and access it. So it's kind of a fun exercise. First, if you still need to install S3FS, you can do that with Homebrew. I already have it installed. I think my -- version will show you that I have version, Amazon's simple version 1.87, simple storage service. And I can switch directly. So to the next piece, I do need to, in order to mount the object storage, I need to identify myself. For that, I need access to the credentials. For that, I need access to the access key and the secret. Set it to a password, and I use that. Now, I could retrieve those from command line right now. Actually, what I can do, I can echo these out because we already set these. So it's like cos, what is it again? Access key and secret key. So cos, access key is that, and COS secret key is that. So I can create these on my local environment. So I set in my Mac, I just copy paste. You could actually log into your IBM Cloud environment here again. But just for the demonstration purposes, I'll just copy paste it. And the secret key set here. So now we're good to go again. And you can also retrieve these by going to the service credentials in the UI. And you can unfold it here, and you see the COS hmac keys with the access key and the access key ID, I should say, and the access key here. The secret. Yeah. And we use these two to create a password file with access key ID colon secret key. Yeah. That's what we'll do here. So we can view the commands that we do. So I set first the COS S3FS password file name to S3FS password. That's just a file name for the password file, and then I can do echo out the COS access key colon COS secret key, and this needs to be written, I should say, into the password file. So COS S3FS password file, and now if I do an ls, if I do a cat out of my COS S3FS password file, I should now have the actual value column with the actual value for the access IDs and the key ID and the secret. So that password file then needs to be given the permissions 0600. And then I change mode. Oh, I just did it. Okay. I'm actually in my present working directory is just my user root directory. So what I'm going to do is I'm going to create a make dir temp2. I'm going to move the password file. You should probably do this already prior to doing this, or you don't need to do this if you don't want to. And I'm going to move this to temp1. See if that went correctly. That's there. It's set. Yeah. So I'm then going to move into temp1. Yeah. So that's in my current directory. I just have this file. I don't want to expose anything else or show you any other mess I have in there. And then next I can continue by the actual mounting. For the actual mounting, I need the public endpoint. So the public endpoint is given here in the subdomain. Subdomain includes the pointing to the S3 service, but it also points to this region. In my case, the region is US South. You can find the region if you go to your object storage dashboards to buckets. And it needs to be the region of the bucket. And you might have buckets in different regions. And here I have a configuration option in the left. And if I scroll down, I see endpoints. I need to look for the public endpoint. And my public endpoint is this. If you're in a different region, if your bucket is in a bit different region, then this endpoint might have S3, your region, .cloud object storage .appdomain.cloud. So that might be slightly different. So make sure that's what's happening. It's described here how you can find it. I make a local directory. Yeah, so I make a data directory. And it's this data directory that I'm going to mount to my object storage. I set the local mount point to be my present working directory, and this command $ parentheses, it interprets the command, so it outputs that command's value to my present working directory / cos data. Yeah, so you see here COS data, and then I set my COS public endpoint to the S3 and then the region in which your bucket is. Mine is in US South. It's for the cloud object storage. There we go. App domain cloud. I can make sure that this is set correctly. Echoing it out. Yeah, set correctly. And then I can try I can attempt the actual mount, which is S3FS I reference the bucket that I'm trying to mount. And I'm not sure, I don't think I set the bucket actually. So let's do that first. Because I'm in a different environment, I need to set the COS bucket name. And if I echo it out in my labs environment, I copy, paste it into my local Mac terminal. Yeah, that's correct. Now I can do the full command again. S3FS with the COS bucket name. I'm going to add some parameters like password. File is set to the present working directory, and the COS S3FS password file. Another one. Another variable set to URL equals HTTPS, and then my COS public endpoint. Yeah, that's at s3.ussouth domain, and the local mount point, which is the data directory I created. Local mount point. Yeah, and hopefully that works. No error, so maybe that's a good sign. And lo and behold, I read the content of my directory, and there's a hello world.txt. And maybe if I go into this cast data file directory. Yeah, so I'm now inside, if I do present working directory, you'll see that I'm actually mounted on my local file system. And I can maybe hello you too into a hello again file. Missing quotes. And I'm basically just working as if I'm working in a real, you see there's a bit of latency here because it's each time, oops, let's rename that error. I accidentally added this question mark apparently. It's a good test. Hello world again. Hello again. Let's do hello again. Yep. Is it? That's it. So that's interesting. It's not recognizing, but maybe I need to use double quotes. Okay, so it's not letting. I don't know where that question mark came from. We'll do it here. Interestingly enough, here you'll see that I'm in my Max Finder. So and I go. You see this OSX-FUSE is the that's how the FUSE works on Mac. So if I remove the question mark here. So, and this is just a fun little experiment to show you that it works both in the Finder as in the terminal. And what we can do next, let's see if there's any, oops, sorry, I moved very fast here. So here you see it renamed, that's my fault. What we can do next, let's see if it tells me anything else. No, yeah, no, okay, so that's good. I can now go to my cloud object storage, and go to my bucket, and I can see if my other file is listed there. So, oh yeah, hello again. So that is pretty cool. So now we can actually interact with our file system, and the data gets stored to our object storage, and then someone somewhere else might be sharing that data through, maybe they have an object storage CLI and they're interacting with it that way, and they're retrieving the data their file, or they might also have mounted their file system to be mounted to the object storage. So who knows? Anyway, I hope you learned a few fun things here and there here in this tutorial. This demystifies a little bit how the IBM Cloud Object Storage plugin works, and it demystifies hopefully also the S3FS-FUSE plugin that you can use to mount object storage as a local directory. So hope that was fun. That was awesome, and I hope to see you next time.